Hello Internet, welcome to the most important tutorial of microcontroller 8051. If you ever wish to do programming flawlessly in 8051, then this tutorial is a quintessential one. Now, this tutorial focuses indirect addressing mode. Now, indirect addressing mode can be used to transfer data from internal RAM to accumulator, and it can also be used to transfer data from external RAM or internal or external ROM to accumulator. Now you need to be aware of this key point that I just mentioned, that accumulator A is the one that is going to be involved in all the data transfers while using indirect addressing mode. So especially when we talk about using indirect addressing, which as a matter of fact is the only addressing mode when we do data transfer from external RAM and external and internal ROM. So indirect addressing mode is super important. Accumulator plays a vital role in external data movements, and the symbol for indirect addressing is @ sign or @sign. And how does it work? So we are going to discuss that right now. Now I'll write down 2 points here, which if you take care will never ever lead you to commit a mistake while programming using indirect addressing mode. The first point, now these are points of caution. Now indirect addressing is used by adding the symbol @ along with RP, and RP can only be R0 and R1. This is the first point of caution. And second point of caution is RP must contain a valid RAM address. Please understand, we are doing the first case of indirect addressing using internal RAM. Now what happens is excuse me, if you wish to I'll give you a case here. Let us say we have a register 4A in the RAM, which is a valid register, and the contents of 4A register are some random content, for example 01010010, which is A to H. So A to H is the content in 4A register. Now if I wish to transfer the contents of 4A register, which are A to H, into accumulator, I can use a method known as indirect addressing mode, and in that method what I would do is I'll say move into A A is my destination. Now when I specify the source, which we generally do after this comma, I'll write the indirect address by specifying this address in either R0 or R1. So before we can use indirect addressing, I must put into R0 the address number, which is 4AH. Now please understand, I've put the address in R0 as a number. All the addresses in RAM are 8-bit long. So what I've done here is I've taken that address, which is an 8-bit number after all, and I've put that 8-bit number, which is an address, into R0 immediately, so that if I use R0 later on as a pointer to an address, it can be used easily in indirect addressing mode. So now this instruction will take the address from R0 and it will go to that address and it will fetch the data in that address and will move into A. And we'll do one more example here. For example, we have another register, let us say 7BH, and the contents of this register is 1111 0000, which is F0H. Now if I want to move the contents of 7B register into A indirectly, I have an option. I can put this address into any of these registers. So what I'll do is I'll move this address into R1, which is not being used. Now R1 contains the address from which I want to fetch the data, and I'll bring the data from 7BH register through a pointer, which in this case is R1. So it is very, very important that we must use only R0 and R1 as pointers to the addresses, and all the addresses are going to be 8-bit long in our internal RAM, so there is no way we can make a mistake because these registers R0 and R1 are 8-bit registers, and we'll put a valid 8-bit address into these registers, and if we put a @ sign next to these registers in the instruction where source is specified, it will not be treated as a direct addressing mode, it will be treated as indirect addressing mode, and they'll be treated as pointers. So that is how indirect addressing mode works in internal RAM. Now why is this so important to understand the working of this @ sign? Because all the external moves can be classified only into two categories. The first category can be we could send or receive So if we have an external RAM, we could read or we could write, and if we have an external ROM or internal ROM, we could only read. So I'll draw these two cases and then we'll understand how indirect addressing is used for external data movements. Alright, when we talk about indirect addressing mode for external moves, these are the two cases that we face. Either we will need to send or receive data from an external RAM, which would include both read and write options, and second case could be reading data from an external ROM or internal ROM. Beg your pardon, this arrow shouldn't be here, so we have a unidirectional arrow. The data is only coming into the microcontroller, and over here we have a bidirectional arrow signifying read and write operation. Now, points of caution: all external data moves must involve a register. As I said in the beginning of the tutorial, all the external moves from RAM or ROM must involve a register. In other words, if we want to send something to some external RAM or ROM, we must put that data into A and then send it. If we want to receive something, we must receive the data into A and then we could transfer it to some other place, for example port or SFR or B register or any other register in the RAM. But the only point of contact of microcontroller with the external RAM or ROM would be A, and the registers which are used to hold the data, or in other words pointer registers, are again RP, which can be R0 and R1. If we want to point ourselves into some address which is 8-bit long, we could use R0 and R1. If we want to point to an address which is 16-bit long, then we have a provision of using DPTR, which is a 16-bit register and is composed of DPL and DPH. And the third point of caution is that the external moves are done by using the instruction move X, and obviously the source will be accumulator whenever we are wanting to read it, and whenever we are wanting to write it, the source will be accumulator again. In case of reading, the destination will be accumulator, and in case of writing, the source will be accumulator, which is pretty understandable from the first point. Now I'm going to write down some instructions and we'll see how they work. The first possible instruction is move X, and we can bring the data from an external RAM which is 256 byte long. So a 256 byte long external RAM would only have an 8-bit address, so we can safely put the address in RP. So this is case 1 when RAM is 256 byte, or more precisely external RAM is 256 byte, and the inverse of that is also possible. We can use this also. We can send the data to some external RAM's location, but before we do that we must put the address in R0 and R1, which is explained earlier. Now, one example is if we wish to send the data to, let us say, 30H register, and the data that we want to send is 10101010, which is AAH, then the code would be simply I'm going to move into R0 the address where I want to send the data. So now R0 is being made as a pointer to an external register which is 8-bit, which has an 8-bit address, and then I'm going to use MOVEX at the rate R0. So, and firstly I'll need to move into AAH. So this code will do this job. So I've written down 10101010 in A and in the first step, and then I've moved the address 30H into R0 register. Of course it will be moved as a number, and then R0 is acting like a pointer here by placing an @ sign next to it, and using an X would ensure that this goes into the external RAM and not into the internal RAM. And another option could be, the second case could be, the external RAM is big enough. External RAM is 64K in size, then the address would be 16-bit. I highly recommend watching the video where I explain how to calculate the address bus or the number of address lines in any memory. That is highly recommended, because a 64K external RAM would have 16-bit address bus. So I'm assuming that you know this, and when we need to send the data to some 16-bit address, then we must take help of DPTR, and for that we have an instruction move X. Of course, if you want to bring the data, then we have A@DPTR, and if you want to send the data, then we have, but everything will happen via A. Now the data in A will go into some register in the memory which has a 16-bit address, but the address itself would be an 8-bit address. And finally, we have the case of internal and external ROM, where the only possible instructions are reading instructions. So the only possible instructions are move C. So this has taken its origin from C stands for code. So code memory is normally a ROM which is permanently burnt into. So move C, A will use indirect addressing, but here the indirect addressing is used as a combination of address made by adding up A plus DPTR. Now this is again very simple. If you've understood the concept of pointing to a register, then if we wish to point to, let us say, A, B, C, D, H location, then we have too many options to do that. We can either put A, B, C, D into DPTR, and we can put 00H into A, and if you add up these two, they'll give A, B, C, D, and if we use this command now, it'll bring the data from A, B, C, D, H into A. So there are numerous ways of generating the address by adding up two numbers. Had we used A, B, 0, 0, then we would have to put C, D into A. This is another way. So numerous permutations and combinations are possible, but the end result of adding these two registers should be that address from where we want to fetch the data. But the fact of the matter is, every external move, may it be from external RAM or external ROM, would happen only through A and via indirect addressing. So the things are very simple. We make them complicated by creating some random instructions of our own, but if you stick to the very basics of points of caution, then you would not make a mistake. So that was it for today's tutorial. I guess this tutorial was helpful, and if you liked this video, then please give it a thumbs up and subscribe to the channel. It is highly appreciated. Any support to the channel means a lot, and you have a very good day and a very good life. Have a bright day ahead. Bye.